but we can tell that the original liquid is not a single substance. It's not a pure substance there. There are two things in there. One is a liquid, the other is a red solid. Okay? And then when the evaporation happens there, you end up with the solid and the liquid is formed. So it's a homogeneous mixture. So answering these type of questions requires you to know how we define those different terms there. Okay? Another example here, a pure substance is heated, in parentheses there, in the inner atmosphere, meaning the chemical under heating is not reacting with whatever is in the air, oxygen, nitrogen, whatever you have in there. Okay? And then it breaks up into two different pure substances. One is gaseous, the other is solid. Is the original pure substance an element or a compound? It's a compound, because element would have the same type of atoms together. You cannot break up elements by chemical means. A compound is something that has two or more different elements combined together chemically. As a result, using chemical reaction by supplying enough heat, you can break that compound apart into smaller, simpler substances and two different pure substances. So these are the type of questions, for the first learning objective, these are the type of questions that we need you to answer. And there are a whole lot more similar type of questions in your homework assignments. And again, the 111 questions assigned in chapter 1, 2, and 3, that's the minimum I need you to do. Okay, and there are more. If you want to do more, definitely there are more. And at the end of each chapter there, end of chapter questions there, you have a whole lot more questions in there. So make sure you take the time and work on those problems as we go along. And we want to emphasize here is that when you have a molecular compound, the reason that I put this word in parentheses here is that there are different types of compounds. We have ionic compound, we have molecular compound. The smallest unit for molecular compound is molecule. Okay? And if you try to break up the molecule into smaller units there, you are changing the identity of that compound. And how do you define molecular compound? How do you define ionic compound? We will get to those terms a little bit later when we get into the details about the structure, if you will, or the composition of different types of matter. Okay, so we want to move on to our next learning objective. The second learning objective there, we are looking at some changes there. Now, when we were having the discussion in the first learning objective, and we give you definitions there, and we can say, well, you can break up a compound into smaller, simpler substances by conducting a chemical reaction. One of the examples that we give you there is that you put water in a beaker, and then if you have electrodes and connect the electrodes to the battery there, over time you can decompose water into hydrogen gas and oxygen gas. So that's a chemical change happening. Now, if you have a piece of ice, you hold it in your hand, ice will melt. So going from solid state to liquid state, or if you heat up water and it gets into the gas phase, well, going from liquid to gas, and there's a change happening here. So in this particular learning objective, we want to talk about different types of changes: physical change, chemical change. How do we define them? That's another D word. How do we define these changes there? And we want you to be able to describe what is the physical property related to physical changes only, and what is physical change for us, and then what is a chemical property, chemical change there. Now, when you deal with physical properties there, we also use two different terms to describe those the physical properties. So one of them is what we call extensive property, extensive physical property, and the other will be intensive. So we want you to know these definitions. So again, the first two learning objectives there, well, in this course, and pretty much it's about definition, it's about calculation. So we're going to go through, we are going through a lot of definitions right now, and make sure that you pay attention to how we define each term. Okay? Talking about the physical and chemical properties there, and a physical property is a property that a substance displays without changing its composition. Water going from solid to liquid to gas, it's still water. Okay, so in this case, the chemical property, however, is the property that the substance is displayed when there is a change for its composition, in the composition of the compound. So a chemical reaction actually happens there. When you have a chemical reaction, that's a chemical change. What are the examples of physical property and chemical property? Well, the smell of gasoline, using gasoline as an example. The smell of a gasoline, the smell, odor, the taste, the appearance, the melting point, boiling point. Those are the physical properties there. Those are the properties associated with only the physical state of a particular matter. Chemical properties, still using gasoline as an example. If you toss a match in the gasoline there, it will violently react with the oxygen gas in the air. And so flammability, that's a chemical property for gasoline. So there are different types of properties there. We need you to know which one is a physical property, which one is a chemical property. And remember things that are related or being displaced for properties that displays by that a substance display without changing its composition. That's how we define physical property. And then on the other hand, chemical property, and chemical property is something that associated with chemical changes or a chemical reaction. Okay, so these are the definitions there. And talking about the physical change, and again, the definition, changes that alter only the state or the appearance, but not the composition. That's how we define physical change. Okay, and atoms and molecules that compose a substance do not change. Water, an example there, water is still water, H2O. That's the fixed composition for a compound that we call water. And when you have when you undergo a physical change there, the identity of the compound does not change. If you alter the composition there, you change the identity. Okay, so this is a picture that you see in your textbook there. And again, we do this on a daily basis there. You boil water there. So liquid water is H2O. Gaseous water is still H2O. When you freeze it down into ice, the solid water, the composition there still is H2O. There's no change in chemical composition. Okay, now chemical change, however, is different. If you build a deck, you put a metal nail on it, and brand new metal nails, sometimes they're made of iron there. Okay, now over time, rust happens there. Now rusting of iron is a chemical change because the composition here is no longer pure iron. It's iron oxide. Oxygen in the air combined with moisture and have a chemical reaction with iron, resulting in the formation of iron oxide. So you can see the pure metal versus iron oxide. These are two different compositions, two different matters there. So this is how we define chemical change. Okay. So again, definitions are very important, and in order for us, when we ask you questions, in order related to these different terms there, you have to know the definition in order to answer those questions there. Okay. And another part, and the next 3 or 4 slides there, and it's like, where does this come from? Well, energy is always a part of physical change or chemical change. Whenever you undergo a physical change or chemical change there, it uses energy. It either requires energy to be put in, or it releases energy. So we have to emphasize here, and there's always, and for any change there, physical or chemical change, and there's a chemical reaction perspective, there's also an energy perspective there. So for that matter, we want to throw in this term there, and there's always energy involved in any changes here. Okay. Now there is a chapter that we will use, in chapter 6 actually, we'll use the entire chapter to discuss the energy aspect of chemical changes there.